Good morning, everyone, and welcome to another exciting version of Chip Talks. Today, we're going to talk about the heart and really kind of pretty much all of the conditions of the heart, let's say, things that might go wrong with the heart. So, we're going to dive into that pretty good. Today's episode is brought to you by our wonderful sponsors, TrueMedx. So you can find TrueMedx products at www.truemedx.com. Neighborly Nutrition. Neighborly Nutrition is where we're broadcasting from in our secret bunker in Ada, Oklahoma, which is literally just right outside of Ada. We're 3 minutes from the, cement plant. Okay, so we're not that far out of Ada. And we do this under a banner called Treat the Cause because we feel like we're on it. I mean, we understand what the cause of most human disease is. And that's what we're talking to you guys about, which is pretty cool. So we're going to get into that with the heart, what that means as we look at the heart and kind of how the heart works. And we're going to go through this kind of symptomatically. So if you have heart disease, if you have things going on with your heart, we're going to kind of address each little category of stuff that could be happening, with heart disease, including plaque, okay? So plaque is kind of a big deal, and we'll walk through what plaque is and talk a little bit about that. So if you're having, blockages and things like that as far as heart disease, then this will be a good talk for you to kind of listen to, and we'll talk about what's going on and kind of the reasons for it, okay? Because the heart disease, there's only one case where heart disease isn't symptomatic. And in that case, it may be symptomatic of something, going on with mama, but, we don't know yet. And gestational diabetes, things like that. So it's really just with congenital. Well, we'll get into it here because I might as well not tell you that now and then have a whole thing about it that I need to talk to you about when I get to that point on the screen. So we'll go ahead and walk through this now. These are I just sort of pulled this up over here on the right, the cardiovascular disease, and these are the main categories of cardiovascular disease. So we're going to go through all of these, but this one, congenital heart disease. So again, this is something where you're born with a heart defect. So you're born with something that, it could be a hole in your heart. It could be a lot of different things. Now, why, again, that's unknown at this point, but God usually doesn't do this, right? So God usually doesn't, there's usually reasons, okay? And right now we're completely ignorant of what those reasons are, so we don't even know how to defend ourselves against this kind of stuff. But, generally there's a reason. Every cell inside of us always wants to be perfect. So if in development some cells are not coming out perfect, then usually there's a reason for that. There's a trauma, there's an insult, there's an injury, there's an infection, there's something, right? Because every cell inside of you is always striving toward God's perfect expression, all right? But congenital heart disease. So congenital heart disease are present at birth and can affect the structure of a baby's heart and the way it works. They can affect how blood flows through the heart and out of the rest of the body. Congenital heart disease can vary from mild, such as a small hole in the heart, to severe, such as missing or poorly formed parts of the heart. Now, the nice thing about this is generally, this is the heart will repair itself, right? Which is kind of really cool. So, and that has been seen in a lot of different cases. So there's a lot of babies that are born with, congenital heart disease, and they get better and do fine, into adulthood. They may not always have the most perfect of heart, but your body sort of recovers from this. Okay, so I wanted to cover that one first. So we'll kind of get into everything else here on this list. So we'll go through this list pretty good. Okay, so first of all, I want you to kind of just consider something, because this is just logic. And I know we're talking about the heart, but what does the heart do? Well, the heart, and I really want you to look at the graphic, don't read the words on here, but the heart is trying to always move blood, right? So in and out, in and out. And so why? Well, again, you need to be able to carry blood to almost every cell in your body, because blood contains oxygen, which cells need to be able to run. And blood contains mediators and kind of food and, let's say, immune mediators for things that are going on in your body. So if you think about your blood vessels, they're constantly in this expanding out and trying to sort of touch cells that need them and then deliver blood and deliver nutrients, to areas and things that need them. And then sometimes they'll pull back, right? So that we'll talk about that in more detail in a second, but I just want you to kind of get that in your head that's what, the heart isn't just sitting there doing nothing, right? It is pumping blood, and it's pumping blood so that you can deliver all food, oxygen and immune mediators out to every cell in your body. So you're a pretty complicated machine, and this is a very big part of, let's say, your wiring and machinery, is how your heart works and how your heart works through your blood vessel system. All right. Okay. So what causes blood vessel growth? And if you hear the magical doctor words, what are the magical doctor words here? So it's angiogenesis, and angiogenesis is the growth of blood vessels from existing blood vessels. So as blood vessels expand and grow, that's called angiogenesis. Okay. It occurs throughout life in both health and disease. So again, it's, you're constantly doing this. Every time that you sort of breathe and then your heart pumps, you're doing this in parts of your body. So, okay. And it's the way that we don't really think about this, but let's say, well, I got all kinds of ant bites all over my hand. So you could look at my personal Facebook page about all that. But I have, an immune reaction happening, let's say, in my hands. And so I need a lot of immune mediators to be able to, fight the venom, the ant venom and the inflammation and all that. Well, how does that happen? Again, it happens in my blood. Those immune mediators are built in bone. Again, they're differentiated from stem cells in bone, and they have to be moved to this area. And how they're moved to this area is in blood. And then the, dead soldiers, the stuff that they, kill and or mediating, and the bad cells, they move out in a lymphatic system, okay? So you kind of have an inbound system, which is your blood system, and you have an outbound system, which is your lymphatic system that kind of takes out the trash. All right, so angiostatin is a protein that's involved with angiogenesis. So if you're expanding out blood vessels, how do you stop? Well, the way that you stop is with an angiostatin. And an angiostatin will shut down that growth. So interestingly, cancer and a lot of, let's say, bacterial metastasis, meaning, not cancer, but disease-causing things, have this growth factor, and sometimes it is, this vessel growth factor turned on. They've got just the gas pressed to the metal, the pedal to the metal. And so angiostatin could be definitely anti-tumor, and so that's what kind of this thing is saying here. It inhibits primary and metastatic tumor growth by blocking tumor angiogenesis. So a tumor can't go out and find food in the presence of angiostatin. But anyway, its primary use and site of use to sort of, you're going out and expanding out your blood vessels. Well, how do you sort of stop and pull back? Well, it's angiostatin, and it's the protein that's involved. Okay. And again, I didn't even need that. So that was the graphic that I showed you earlier. Okay, so let's look at blood pressure real quick. And I want to so we're going to kind of pop down this list. Again, high blood pressure. So coronary artery disease, we'll talk about in a second, but high blood pressure, let's talk about just real quick. So what causes high blood pressure? Well, it's inflammation mainly. So chronic inflammation leads to damage in the lining of the blood vessels, and that inflammatory response can lead to things like arterial stiffness, which generates higher and higher blood pressure. Okay, so again, all of this is correctable though. Again, there's ways to address chronic inflammation, and there's ways to address and correct, arterial stiffness. But we need to begin to understand, instead of sort of, let's say, treating every little fire that pops up, we need to really look at the source of the fires. And, that's what we're going to get to here, because generally this is what causes chronic inflammation. So chronic inflammation is causing high blood pressure. Well, what causes chronic inflammation? Well, it's, again, pathogenic, intervention. It's you're infected with something, or you have a trauma, but you're infected with something. Okay. All right. So what causes a heart attack? Is it just, your heart decides to go bad all of a sudden? No, there's absolutely a cause for it. And it's again, the heart is a symptom, right? So it's going to be symptomatic of other things that are going on. If you're not pumping adequate blood into that muscle, again, it's going to spasm. Okay. It's just like, if you don't have adequate salt and blood in your calves, and you step on them wrong, you're going to get a big spasm in your calf, right? So it's the same kind of thing with your heart. If your heart isn't getting kind of the nutrients that it needs, and it's not getting, it's not functioning kind of in the way that it needs to, it's going to spasm. You're going to have a heart attack. What causes this? It's plaque. Again, a heart attack, also called myocardial infarction, happens when a part of the heart muscle doesn't get enough blood. So it's not getting what it needs. Again, it's going to spasm. The more time that passes without treatment to restore blood flow, the greater the damage to the heart muscle. Coronary artery disease is the main cause of heart attack. So coronary artery disease is the main cause of heart attack. So what's coronary artery disease? Coronary artery disease is caused by plaque buildup in the wall of the arteries that supply blood to the heart, called coronary arteries. Plaque is made up of cholesterol deposits. Oh, is it? Is it really? Partly. So we're going to talk about this. Plaque buildup causes the inside of the arteries to narrow over time. This process is called arterial sclerosis. And again, if you are showing up for arterial sclerosis, then you're at risk of a heart attack. You're at risk of, you don't have enough blood flowing through you. Again, you're not able to send all these mediators around as well as you should. You're crashing and burning rather than, sort of going the right way. So we don't want coronary artery disease. Again, how do we prevent, this buildup of plaque? Apparently it's caused by cholesterol. Now, let me tell you why I find that hard to believe, okay? And then we'll talk about what this really means in a second. But plaque is made up of cholesterol deposits. No, it's not. You need cholesterol. You move cholesterol around your body all the time. Cholesterol is fundamental to how we build cells. Cholesterol is fundamental to our brain health. 40-something% of your brain, if I remember right, is cholesterol, okay? So we've got to have cholesterol, and it's a very important process in our body. So I don't think God is a perfect engineer, right? So I don't think God would design a system where something very important was also the thing that killed you. Do you? I mean, that seems like poor design. So that isn't what happens. So cholesterol is kind of the cause of plaque, but we'll talk that through. Okay, so there is a byproduct of cholesterol that is called oxycholesterol or oxysterol, okay? And it's just when basically an oxygen group has been attached to cholesterol, but that modifies cholesterol and it makes it bad for us. And oxys are going to be the cause of a lot of things that are bad. What causes oxysterols to form? We'll talk about that in a second. But oxysterols are what cause plaque, okay? So look at this. So this is a study. Again, it's an old study, 1999, all right? So, I guess we've known about this in science since 1999, or at least Mr. and Mrs. Brown and Mr. and Mrs. Jessup have. Those are the researchers. So let's read this. Oxysterols are present in human arteriosclerosis plaque and are suggested to play an active role in plaque development. What? Didn't we just read that plaque is made up of cholesterol deposits? But now we're finding it's oxysterols that we've known about since 1999. Moreover, the oxysterol cholesterol ratio in plaque is much higher than in normal tissues or plasma. So again, God's designed thing, cholesterol, is not going to kill you. Something else has to happen to it before it begins to cause damage. And that's this oxysterol situation. Oxysterols in plaque are derived both non-enzymatically, either from the diet or from in vivo oxidation. So again, we may be eating these things in our diet, And for instance, 27-hydroxycholesterol are formed enzymatically during cholesterol catabolism, okay? So important thing here, because these are the guys that form plaque, okay? They combine with cholesterol to form plaque, but this is what forms plaque, oxysterols, all right? Now, let's continue on our journey here. So what else do we got over here in heart things? So we've got peripheral artery disease. So if you've got that, you might have neuropathy in your feet. This is something that kind of happens with diabetes. You might have your legs sort of that aren't getting proper blood flow. This happens a lot to older people, okay? So peripheral arterial disease in the legs or lower extremities is a narrowing or blockage of the vessels that carry blood from the heart to the legs. It is primarily caused by, wait for it, the buildup of fatty plaque in the arteries, which is arteriosclerosis. So again, we're right back here to coronary artery disease as the cause for peripheral arterial disease. Isn't it nice how medical science creates all these things from just the same thing? I guess they're billing codes in Medicare or something. I have no idea why would you just call this plaque? Because it's just plaque. All right, so let's move on to another one. What is a stroke? Most ischemic strokes are caused by arteriosclerosis. What? Coronary artery disease? Yeah. So again, this is the problem, coronary artery disease, okay, that will cause a stroke. So this happens with fat and cholesterol buildup in your arteries, except this is a lie. It's not cholesterol. It's oxysterols combined with cholesterol build up in your arteries or blood vessels, causing your arteries to narrow. Over time, this can completely block blood flow, which will cause a stroke. All right, so you guys are getting the picture, right? Okay, so let's, again, almost every, except congenital heart disease, that it probably has a cause, but I don't know what that is right now, and we'd have to do a lot of research into moms and all kinds of stuff and kind of what happens there. Environment, it could be environmental, it could be from dad somehow. There's just 100,000 reasons why congenital heart disease could happen. But that does happen, and that is not really, I would say, related to every other type of heart issue. Every other type of heart issue is going to be sort of a consequence. It's going to be a symptom of something else, all right? So your heart just doesn't go bad. Your heart just doesn't quit beating. There's something else that happens in that scenario. And the most likely things to happen are that you get chronic inflammation, that you go into some kind of a crash, and that because we don't understand really our cholesterol status, how these oxysterols are formed, that we somehow inadvertently put ourselves in a situation where we're building a lot of oxysterols inside of ourselves. And when we do that, we're going to have heart disease. So if you're building a lot of oxysterols, you're going to have heart disease, okay? Oxysterols, I'm going to read you this because, again, and I'm going to explain this as I sort of go through and read, because I think this is important. Oxysterols are structurally close related to cholesterol. How are they related? Again, they just have an oxygen group, and it's an OH or just an O, but they have some kind of oxygen group just glommed onto cholesterol. And there's a lot of different versions of these guys. In fact, they're actually over here on the left. You can see some of them. But there are a lot of different versions. You can see how basically OH is, glommed on here on the left. You can see here where there's two OHs on the left and the right. You can see a HO and an OOH over here. So again, but these are just different versions of oxygen that are glommed onto cholesterol. So oxysterols can be defined as oxidized forms of cholesterol or as precursors. They are formed mostly by cytochrome P450 enzymes. So that happens in the liver, okay? And cytochrome P450 is what gets activated when we think we have some kind of toxicity, okay? So when we're trying to get rid of something, again, cytochrome P450 is what gets rid of, drugs that you take and all that. So they're the enzymes in the liver that break down kind of toxic things. So it's interesting, we'll dive into this further later, but there has to be almost some toxicity for this to happen, okay? Oxysterols can also, and what I mean by that is infection, chronic inflammation. Oxysterols can be can also be formed via non-enzymatic reactions, both in vivo in the body and ex vivo outside the body. So you can create a chemical reaction to form these guys outside of the body. They are bioactive molecules, meaning they signal, they are involved in intercellular communications. They are involved in cellular communications, intercellular communications. So they are bioactive molecules, which should, send everybody into a and their manifold and complex functions are far from being completely known or understood. And boy, is that the truth. Some examples presented here should illustrate that oxysterols are key molecules in embryonic and fetal development. Okay? So again, oxysterols could be involved in congenital heart disease. We just don't know it yet. Like cholesterol, they are ligands of SMO, one of the key proteins of the hedgehog signaling pathway. Now, hedgehog is a pretty darn important signaling pathway. Some oxysterols are important regulators of cholesterol hemostasis, as they are activators of the liver X receptors. So liver X is a pretty important receptor in your liver that turns off and on a lot of pretty important processes. Via LXR, oxysterols also regulate neural progenitor fate, okay? Cholestynoic acid, which is a metabolite of oxysterols, tunes the balance between survival and death of motor neurons. So they're involved in how we do motor neurons. Oxysterols are products during bile acid synthesis. The alternative pathway of bile acid formation, see also bile acids, comprise many more active intermediates than the classical pathway. It is interesting, the alternative pathway predominates early in pregnancy. So again, we're making oxysterols for some reason in pregnancy. In pregnancies affected by FGR, preeclampsia, or gestational diabetes, changes in oxysterol levels in fetal and maternal serum and in placental tissue compared to healthy pregnancies are observed. So in certain situations with moms, again, you're going to get more oxysterols. Now, interestingly, oxysterols are part of the, and I know we're talking about the heart, but this really has to do with oxysterols. And again, oxysterols are what form plaque. Plaque is what's going to be the majority of heart disease and it causes the majority of heart attacks, okay? Plaque is what's going to participate in angiogenesis and sort of wreck that process. So it's all about the plaque when you look at heart disease, and it's not about cholesterol, and that's what I want you to know. It's really about these oxysterols. But oxysterols are even involved in the pathology of autism, okay? So the signaling of autism. So, what's going on here? Well, we're going to get to the bottom of it, but this is close to the bottom of it. Your body, for some reason, is doing, instead of taking this pathway with bile acids, okay, it's all of a sudden taking this pathway with bile acids. And why that happens, again, it's probably pathogenic, and pathogenics that can control that switch, but that favors the pathogens, right? So when you have a bunch of oxysterols, that's going to favor pathogens over the other bile pathway. Why? I'm not sure yet. We'll get to the bottom of that, but I'll tell you when I know. And it's not that hard to get to the bottom of. It's a 30-minute dig, right? So feel free to do it on your own. If you figure it out before I do, then let me know. But those two bile acid pathways I've looked at before, and they're super important in health, and they are already know there's something that get hijacked in, let's say this bacterial hijack. If you're have kind of a metastasized bacterial situation, and again, that doesn't necessarily mean cancer. That can mean a lot of other things. It could mean Epstein-Barr, it could mean HPV, it could mean pylori, it could mean a bunch of other type bugs. But if you have a metastasized situation, this is part of the pathology. Again, the bile acid pathways get hijacked, okay? And you go to this alternative pathway that they're talking about that also happens in pregnancy, which is fascinating, and that's new information to me as I was kind of doing this dig, which is good. Depending on the type and concentration of oxysterol formed, they may or may not only impact on the fetus, but also on formation and function of the placenta, the organ required for hemotrophic nutrition of the fetus. Imbalances in the concentration of oxysterols can contribute to pathophysiology in adult tissues, for instance, in the eye. So, and again, isn't it interesting? I wonder if oxysterols have to do with hair loss. Let's see. because I always use the example, teeth, eyes, and hair, right? So why do we lose those before we die? Well, looky, cholesterol homeostasis, links to hair follicle biology. And look at all the... Oh, apparently you can use an oxysterol to reverse hair loss. Interesting. So, again, are they involved in hair loss? Yeah, looks like it. Lots of studies here, lots of NIH, lots of sciencey science. So, again, and I would imagine that if you look at teeth, they probably are involved in that too. Let's just look. Maybe not. So teeth maybe go bad for another reason. But anyway, they're involved in a lot of stuff. So we're going to do a little bit more investigation on oxysterols, certainly over the course of things. But they are no doubt the cause of this, okay? So this is kind of a lie. Plaque is made up of cholesterol deposits. It's really made up of these oxysterol deposits and cholesterol. According to what old Mr. Brown and Mr. Jessup, or Mrs. Brown and Mrs. Jessup, found out in 1999. So, again, the big thing here is if you're having heart disease, there is a solution to this, and the solution is going to be, the easy solution is behavior and diet, although for a lot of us that's hard. The kind of one pill solution, sorry, there's not really one here. There's not going to be a pill that makes your oxysterols stop. What the real solution is understanding the underlying. So what situation is causing basically the overproduction of oxysterols, which is causing the plaque? And that's probably going to be bacterial, fungal, viral, pathogenic, okay? So we're looking at hopefully you guys are getting it. I'm walking through all these different disease states and tying them all back to the same cause, all right? And that's why we're saying that we're on it. And treat the cause is looking at treating the cause of disease. Because again, if I can figure this out, if we can figure out all the, let's say, hijacks that this bacterial hijack does, and they've got to do that in order to survive. They've got to build their fort. Again, they're at war with you. They're trying to take you over. They're trying to use your resources. They're trying to, they take things from you. And so what is part of that pathology? Well, it's looking like this bile acid oxysterol situation. It also has to do with COX-2. It has to do with the overproduction of prostaglandins. It has to do with hijacking your type 2 immunity. It has to do with toll-like receptors and how these bacteria proliferate. So there's a lot to this pathology, but it's known. It's pretty easy to get to. It's not like these guys out there shouldn't be working on this stuff. But the thing that it does is it breaks pharma. Okay, so it literally breaks the, let's say, fundamental premises behind pharma, and that's that, sorry, you're going to get sick, and when you get sick, we as little man gods have to be there to help you. And it doesn't work that way, boys and girls. You're built perfect. You're built to always strive toward perfect. We've just got to understand how we work. It's like we were given us without the instruction manual. And we just need a new operator manual. We need a better understanding of how we work. And when we have that, we're going to fly as to health. We're going to live a lot longer. We're going to be a lot stronger. We're going to have a lot stronger immune systems. We won't suffer like we do now, with all the health issues that we do now. So we'll leave it there for today. So hopefully that was useful. Please spread the word, click on the subscribe and like buttons and all that kind of stuff I'm supposed to say. But it helps to get this out and it helps to move these around. Again, I'm trying to give you information. I'm trying to educate you about how you work and human function. And the more people that know, the better for all of us. See you guys later. Love you guys. See you next Friday. Next Friday is anti-parasitics, which will be great.